In this video, we're going to go over reducing after rewriting with rational exponents. And if you haven't watched the first video on rational exponents, it would be a good idea to do that now. Here's an example. I'm going to want you to rewrite this with rational exponents and then reduce the rational exponents if possible. At the end of the process, you'd like to write back into radical form. For instance, here I have the fourth root of 5 squared. After rewriting in rational exponents, I can reduce the 2/4 to a half. And of course, 5 with an exponent of a half can be written as square root of 5. Here's one for you to try. Please pause the video. Using the definition, we can rewrite this as k with an exponent of 4/6. 4/6 reduces to 2/3, which would become the cubed root of k squared. Here's another. After rewriting in exponential form and reducing 3/6 to 1/2, we can rewrite this back as the square root of 49, and of course that's just 7. Try this one. Here, it's important to notice that in the radicand we have two bases that are the same, and we also have a product. By order of operations, I would begin in the radicand, and by the product property, I would keep the common base and add the exponents. 12 plus -6 would just be 6. Next, I would rewrite this in exponential form and then reduce the common factor of 2. And last, I would rewrite back as a root, that is the 5th root of x cubed. Next, let's do the same ideas, but this time with quotients. For example, here I have the 8th root of a quotient. And starting in the radicand, I can use the exponent rules to rewrite this as m, because I have a common base of m. So I can rewrite this with the common base m, and then subtract the exponents. In this case, I would have 3, and I would be subtracting a -1. Subtracting a -1 would be like adding a +1. So this would have an exponent of 4, that is the 4th power of m. Then I would rewrite using the definition. Of course, 4/8 can reduce to a half, and that would be the square root of m when I rewrite back in radical form. Here's one for you to try. I'd have to begin in the radicand. I have a common base of a, so I can keep the common base and subtract exponents. 9 subtract a -3 would be like 9 plus 3, or 12. I can rewrite this back as a with an exponent of 12/6, which reduces to 2. Here's another. Again, in this case, I would begin by simplifying the radicand. An exponent in the numerator of -2 will be the same as a positive exponent in the denominator, so I would write the 4 squared in the denominator. Then I have a common base of k, so I can subtract exponents. 13 minus 5 will give me 8. Next, I would use the idea that each of these is a 4th root. So I'll get k with an exponent of 8/4 and 4 with an exponent of 2/4. I can reduce 8/4 to 2 and 2/4 to a half. And in the denominator, 4 with an exponent of a half can be written as square root of 4, and that simplifies to 2.
Well, that will conclude this video where we've practiced reducing after rewriting with rational exponents.